Good afternoon, Spartan fans, or good morning, depending on when you watch the video. We're going to do the second part of 7-7, and you for sure want your handy dandy identity sheet. Okay, before I get started, I just want to review something. When you have the sign of whatever, 30 degrees plus 45 degrees, this does not equal the sine of 30 plus the sine of 45. And if you're not sure, check on your calculator. You cannot distribute sine. It is a function. It is like saying the log of x plus 3, right? If you were to graph that, it would be shifted left 3 units. This does not equal the log of x plus the log of 3. Okay, so it's that same concept. You cannot distribute the function. Okay, so let's look at, we're going to do a bunch of evaluating, and the key part of today's lesson is if you can label the triangle, you can evaluate whatever you need. If you can label the triangle, you can evaluate whatever you need. Okay, here we go. So there's a problem similar to the one I'm going to do in the book. You are given... I love my drawings, they crack me up. You are given a circle and some angle alpha, and you are told that the coordinates of this point are x, comma 1, and that the equation of the circle is x squared plus y squared equals 4. This looks so much harder than it is. The radius of this circle is, you got it, 2, so there's your hypotenuse, the radius, and then y is 1. Well, guess what? Can't you find x? Sure you can. Plug in 1 for y, and you get, I believe, root 3. Now you know all 3 sides of the triangle. And then, again, I'm doing a problem that's in the book. You're given another circle intersecting with an angle that intersects on a circle. And this time you are told that you have some angle that terminates in the 4th quadrant. An angle that terminates in the 4th quadrant. And its intersection with the circle is at 1/3 y. And the equation of the circle is x squared plus y squared equals 1. So when you draw, the radius of this circle is 1. X is 1/3. And then by the Pythagorean theorem, it's going to be negative. Be careful about that. We're in the 4th quadrant, so the y value needs to be negative. So when we plug in, let's see. X is 1/3 squared, that's a 9th. So y squared equals, how about 8/9? So y equals, if we were just flat out solving, we would say plus or minus 2 root 2 over 3. And because we're in the 4th quadrant, this is negative 2 root 2 over 3. You have 2 triangles. Triangle with angle alpha, root 3, 1, 2. Triangle beta, and its sides are 1/3, negative 2 root 2 over 3, and 1. Now you can evaluate absolutely anything that I ask you. So I can ask you to find the tangent of alpha minus beta, plug in. I could ask you to find the cosine, you would plug in, etc., etc. So let's do, I'm just going to randomly choose one. Let's do the tangent of alpha minus beta. And I highly recommend that you write out the formula. So the tangent of alpha minus beta is tangent alpha minus tangent beta over, like I have my identity sheet sitting right here next to me. I'm just writing it down. 1 plus tangent alpha tangent beta. Okay, plug and chug, and just be careful with your simplifications. So tangent of alpha. So the tangent of alpha is 1 over root 3. So that is root 3 over 3. Minus the tangent of beta. This is really gross. The tangent of beta is negative 2 root 2, I hope. Opposite over adjacent, the 3's reduce out, negative 2 root 2, yes. Over, you see how I give myself a lot of room so I don't mess anything up? I probably still will. 1 plus the tangent of alpha, which is root 3 over 3. Times the tangent of beta, which is negative 2 root 2. Gosh, please don't even think about crossing off the negative 2 root 2's. Okay, let's see here. Let's hope I don't mess this up. This is going to be root 3 plus 3. 6 root 2 over 3 over, let's see, this is going to be 3/3. I'm just simplifying. 1 is 3/3 minus 2 root 6 over 3. That's going to give me root 3 plus 6 root 2 over 3 minus 2 root 6. You know, there's very little trig in all of this. There's very little trig. It's a lot of algebra and simplification. Okay, so I'm going to rationalize, and of course I did not leave myself very much room, but I'm going to rationalize and multiply by 3 plus 2 root 6. You know, color coding is a great way to keep your homework and everything else nice and clear and easy to read. The tangents always involve all the roots. That's 3 root 3 plus 2 root 18, which I'll fix in a minute, plus 18 root 2, plus 12 root 12. I hope this is right. I have a really, really bad feeling that I made a mistake. And this is 9 minus 4 times 6. Not like terms, but I can make them like terms. So 18 is 3 root 2. So this is 6 root 2. And root 12 is 2 root 3. So this is 24 root 3. Root 3 plus 24 root 3 is 27 root 3. 6 root 2, 18 root 2 is 24 root 2. All over 9 minus 24, negative 15. We don't want the negative, and we can divide everything by 3. So I'm going to divide everything by negative 3. And that's going to be negative 3. Negative 9 root 3 minus, divide by 3, 8 root 2 all over 5. Okay, I double checked. That's the right answer. Wow. So this literally was a matter of plugging in, and then the rest of it is just a bunch of algebra. There's not a whole lot of trig going on. Okay, so again, it comes down to knowing how to label your triangles. All right, let's do something where you are asked to find a, it's on tip of my tongue, an inverse with two triangles, an inverse function with two triangles. So let's say I ask you to find the cosine of the inverse tangent of 5/12. Yes, this is a problem in the book. I always do examples from the book. Hopefully that will help you with the homework. Inverse sine of -3/5. Okay, I like this. 5, 12, 13. I like this. 3, 4, 5. So this, the inverse tangent of 5/12 is some angle, let's call it alpha, whose tangent's 5/12. The inverse sine of -3/5, let's call that beta. It's some angle beta whose sine is -3/5. Great, let's draw this, whatever triangle it is. It's going to be in the first quadrant because inverse tangent is positive in quadrant 1, and it's a 5, 12, 13. Opposite, adjacent. Okay, here's the deal. You have to be careful because inverse sine is negative in quadrant 4, not quadrant 3. Inverse sine is negative in quadrant 4. So this is 3, 4, 5. You can now evaluate any of those sum or difference formulas that I ask for. This one says cosine. So the cosine of alpha minus beta, hopefully you're starting to realize that it's really important that you have this identity sheet. Cosine alpha, cosine beta, plus sine alpha, sine beta. Cosine of alpha is 12/13. The cosine of beta is 4/5. The sine of alpha is 5/13. The sine of beta is -3/5. Gotta love those Pythagorean triples. So this is 48/65 minus 15/65, which is 33/65. It's all about drawing the triangle and finding the lengths of the three sides. Okay, sometimes you're going to be asked to solve. Sometimes you're going to be asked to solve. And these look a little bit different than what we've been doing. These look a little bit different. So let's say I ask you to solve √3 times the sine of theta plus the cosine of theta is equal to 1. Okay, so when I first looked at this, I thought, I don't know about this, and I'm going to be honest, I had to restart the entire video because it just didn't work out right, and I was irritated. So one thing I did start with that was correct was I squared both sides because I can't do any substitutions, right? Like in the previous ones that you've been solving for, maybe you substituted, tangent squared plus 1 was secant squared or something funky, and this just has no substitutions. So I thought, okay, I'm going to try squaring both sides because that'll give me a sine squared and a cosine squared, and it was super helpful that I was going to be able to take that out and make it 1. So this is going to give us 3 sine squared plus 2√3 cosine sine, sine cosine, whatever, plus cosine squared equals 1. Okay. It'd be great if I could get this equal to 0, then I could use the zero product property, so let's hope. If I take out sine squared and I substitute 1 minus cosine squared, okay, maybe. And so that is what I tried. Didn't work. I couldn't rewind the video. So I tried substituting sine squared was 1 minus cosine squared, and it didn't help me. So how do you know? You have to try. So instead what I did was, and I know that's not super helpful, well, how do you know when you're supposed to substitute this? And how do you know when you're supposed to substitute that? And I wish I could tell you, but there's no set formula for which plugin helps at which time. So what I did was, I subtracted cosine squared from both sides, and that gave me 1 minus cosine squared, which is sine squared. And now I can make it equal to 0, which is always the goal. So when I subtract sine squared, I get 2 sine squared plus 2 root 3 cosine sine equals 0. And now we're in business. Factor out the 2 sine. And that's going to give me the sine of theta plus root 3 cosine theta. How does this help me? It does. Watch. I can use the zero product property. 2 sine theta equals 0. Sine is 0. Or theta is 0, I should say. Now, I think this is not going to help me very much, but indeed it does. So hopefully you can think ahead about what I'm going to do. If I subtract root 3 cosine theta from both sides, divide both sides by cosine, and that's tangent. Divide both sides by cosine, and that's tangent. And this comes down to your unit circle. And let's see, this would be, well, it's either a 30 or a 60. And it's a 60. Negative means quadrant 2. So theta is 2 pi over 3. How do you get that? You practice with your unit circle. Last problem I'm going to do is a proof, and surprisingly enough, I'm actually going to start on the right-hand side. So the secant of alpha minus beta, right away I would be thinking that's 1 over cosine, is equal to secant alpha secant beta over 1 plus tangent alpha tangent beta. This is going to be 1 over cosine. And the cosine involves cosines and sines, right? The cosine of alpha minus beta, which is what, cosine of alpha minus beta is all cosines and sines. That's going to be hard to turn into tangents. So I took this and I said, I like secants better. So secant alpha is 1 over cosine, and secant beta is 1 over cosine. So the numerator is 1 over cosine alpha times the cosine of beta. Over, again, I thought this was bigger and easier to bring down versus having to expand the secant out. Okay, tangent alpha is sine alpha over cosine alpha times tangent of beta, which is sine beta over cosine beta. So I rewrote tangent alpha times tangent beta as this. And then I see, cosine alpha, denominator, cosine beta. The numerator has a denominator of cosine alpha, cosine beta. So I'm going to take that 1. And if you want to use different colors when you're doing your proofs so that I can follow along, feel free. So 1 is going to be cosine alpha, cosine beta over cosine alpha, cosine beta. So it was 1, and then I just wrote over it in blue. Okay. Common denominator. All 3 denominators are cosine alpha, cosine beta. So those can reduce out, and you're left with 1 over cosine alpha, cosine beta, plus sine alpha, sine beta. Okay, so to go from this big step 2 to 3, they all have the same denominator, so the denominators reduce out, and you're left with numerator 1, numerator cosine alpha, cosine beta, numerator sine alpha, sine beta. Well, this is the expansion of cosine alpha minus beta. This is the expanded form of cosine alpha minus beta, which is indeed the secant alpha minus beta. Some of you might be very confused on what just happened from here to here, so I'll just write it again. 1 over, you know what, I'm going to say V is equal, so I don't have to keep writing it, cosine alpha, cosine beta. So this is 1 over V over V plus sine alpha, sine beta over V. So I just didn't want to rewrite cosines. Well, they all have the same denominator. So you're left with 1 over V plus sine alpha, sine beta, which is what happened here. Common denominator is super helpful. Okay, that is the second part and of 7.5.